This video will discuss some of the challenges brought forward by integrating non-renewable energy with our current energy system. In modern society, we use energy for almost everything we do. We use it in our homes, for transportation, and in industry. Globally, our current energy demand relies heavily on carbon-based generators, such as oil, natural gas, and coal. The problem with these generators is that they release a waste product of carbon dioxide into the atmosphere. Carbon dioxide is a strong greenhouse gas, which means it's really good at trapping long-wave radiation on Earth's surface, creating a warming effect. Atmospheric CO2 concentration has been exponentially rising since 1950, and consequently, so has mean surface temperature. Global carbon emissions are only expected to rise in the near future. So what can we do to reduce future emissions? Part of the answer is to transition to an energy system made up of renewable generators. But before we go any further, let me introduce some energy terminology. Dispatchable, an energy resource which can be ramped up or down as needed to meet demand. Non-dispatchable, an energy source where the production is controlled by external factors. This is a demand curve. It has energy units on the y-axis and time on x. The plot shows a duration of time for a given magnitude of demand. The highest point on this curve is called the peak demand. Although the peak may only be present for a few hours per year, the infrastructure to meet that peak must always be in place. To meet the demand, energy can come from three sources. Baseload generators, which run almost every hour of the year, are the cheapest and most efficient. Intermediate generators, which are required for fewer hours, are more expensive and less efficient, and peakers, which allow for quick ramping up or down and are only required for a small number of hours per year. Peakers are the most expensive and the highest emitters. Now let's take a look at some renewable generators. The two that always seem to come up are wind and solar. These are both great options because they don't produce carbon dioxide emissions, and according to the U.S. Energy Information Administration, both generators have zero variable cost. Sounds great, right? Well, there is one problem. These are both non-dispatchable generators. Let's go back to the demand curve for one day in California. We can see demand is lowest at night, peaks in the morning, and again in the early evening. Now let's take a look at the solar power generation for the same day. As you may have expected, it's only present during the day and peaks around noon. When the renewable power generation is subtracted from the demand curve, we're left with what's called the residual or net demand. The residual demand is lower, especially midday due to the solar input. In fact, on this day, renewables were responsible for over 400,000 megawatts of generation. But when we look at this curve, there's a few things you should take note of. The peak residual demand isn't actually lower, which means the installed capacity of non-renewable generators has to stay the same. Also, the lowest point in the residual curve is much lower than the original demand curve. This is a problem because now the baseload generators are operating above the minimum demand, resulting in an overproduction and ultimately curtailment of energy. If the baseload generators are reduced, we end up increasing the need for intermediate and peakers, which were the more expensive and higher emission generators. Finally, notice the steep slopes between the peaks and minimum demand. This is where the grid managers have to ramp up or down to prevent a blackout or overproduction. To do this, they have to be able to predict when the renewable energy will be generating. Well, the sun shines during the day and is strongest at noon. So that doesn't sound too difficult, right? Let's expand our view over time a little bit. This is the solar production for 7 consecutive days in California. The magnitude of solar production can change a lot from one day to the next. This makes it a little difficult to predict how much other generators need to be ramped up or down. Now let's look at the same 7 days, but this time with wind production. As you can see, the duration and magnitude of wind generation can be wildly unpredictable. This throws a bit of a wrench in demand forecasting. But don't worry, we can make renewables great. Energy storage is becoming more efficient. This can help with moving the non-dispatchable energy to times of the day when it's needed. Additionally, installment of more dispatchable renewable sources such as hydro, nuclear, geothermal, and tidal will allow us to transition to a low-carbon energy system. If you'd like to know more, visit the ICEVIC website.